Hi guys, in this video we will see how we can implement fire detection using YOLOv8. So for the implementation of this project, I will be using Google Colab and for the dataset, I will be using a publicly available dataset from RoboFlow. So I will be adding the link of the dataset into the description as well. And let me explain the GitHub repo which I will be using in this project. So you can see that this is the output demo video which I am showing over here. So you can see that we are getting a very perfect results. So in order to get such results, so do watch the complete video tutorial in which I will be explaining the whole process flow step by step. So if you want all this implementation by the end of this video, you will be able to implement this project on your site as well. So you can see that the results are very good and we have tested our model on multiple different videos and we are able to get very fine results like you can see over here as well. So let's move towards the implementation part. Before going towards the implementation part, let me tell you this Colab file will be exclusively available to our Patreon supporters. So here are the different projects which are exclusively available for our Patreon supporters, which are not available on our YouTube channel. So you can check these projects available here as well. So if you join our Patreon support program, you will be able to access all these exclusive projects as well. And here are the different membership tiers. You can check these membership tiers as well. So for this project, I will be using this dataset of fire and smoke detection, but in this video tutorial, we are only detecting fire. We are not detecting smoke. So in this video, our only focus is detecting fire. And this is the complete dataset here or here. I will add the link of this dataset in my YouTube video description as well. So you can check this dataset from there by clicking on the link. And this is the GitHub repo, which will be used for this project. You can see that all the details about how the steps to run code are provided over here. So you can implement this project on your side by following these steps. And you can either implement on Visual Studio, PyCharm, Google Colab, Spider IDE, or any other IDE of your choice, which can be the Anaconda Navigator as well. So let's move towards the implementation part of this project. So this is the Google Colab notebook, which I will be using for this project. So first of all, let's start from the very basic. So first of all, I importing this library from ipython.display import image. Why I importing this library? Because this library is used to if you want to display some output image over here. For example, if you want to display the validation batch results, or if I want to test my model on some image, I can use image library to display the image in the Google Colab notebook. So let me show you where we have used this library over here. So as you can see over here, this is a confusion matrix which we have displayed using image library. And this is the training and validation raw results which I have displayed using image library. These are the results from the validation batch which I have displayed using image library. So you can say that here we have used the image library. So this can be used for multi-purposes. So let's just move towards the code. First, I will clone this GitHub repo. I will just go here and just click over here, copy it and just paste it over here. Okay. So first I will clone this GitHub repo. So let me move on. So first we are cloning this GitHub repo. And then we are moving towards this required directory. Okay, then we will install all the dependencies over given over here. Okay, then we will move towards the required directory over here. Okay, then basically, if you want to download this dataset from RoboFlow, you can download it, this dataset. Basically, how you can download it by just going over here and just clicking on export and show download code and just copying all this from here and just pasting over here. You can just download this dataset. I have already downloaded and trained my model over this from this dataset, so I do not downloading it again. And then you just need to train your model. For this, I'm using YOLOv8s. You can use YOLOv8 Nano, L or X model as well. So it depends all upon your choice. So this model gives fine results. So I'm just using this model as well. So I have trained my model for around 120 epochs, and we were able to get a mean average precision for of with IOU of 50 as 0.576. And if the IOU varies from 50 to 95, our mean average precision is 0.306. And these are not very impressive results, but you can say that these are fine results in terms. So now we are checking the different files after training. We just go to the training folder and see what are the different files available in our training folder. And then I'm displaying the confusion matrix. Uh, so confusion matrix tell us of how our model performs on basically how our model behaves on the classes which we have trained model. So you can see that out of 100 times, 62% of the time, our model detected correctly that this is the fire, while 38% of the times our model was not able to detect that there is a fire as well. So for 62% of the time, our models detect there is a fire, while 38% of the times, our model fails to detect that there is a fire or not. So these are the training and validation loss results. The important losses are CLS loss and box loss for us. While you can see that the loss value is decreasing gradually, like you can see over here, and mean average precision is increasing by time as the epochs number of epochs increase. So this is a good trend. So these are the model predictions on the validation batch. So you can say that our model gives with fine results because these are the images on which we have not trained our model. So these are the validation batch images. We have not trained our model on these images. And as I have already saved my weights of the model weights into the Google Drive of the model I have trained, so I'm just downloading the weights from the Google Drive. After training my model, I save the weights into the Google Drive, so I just don't need to train the model again. So these are the my model results on the validation batch, and you can see that I'm just validating our model, and here on the validation batch, I'm able to get mean average precision of 0.584, and with IOU 50 to 95, it's 0.311. So these are the fine results as well. So I think I've just written this step twice. So just skipping downloading grids. And here I'm just downloading a demo video from my Google Drive and just testing my model over here. And then I'm just displaying because of the video large size, I'm unable to display the results over here. Then I'm testing one's other demo video and just doing the prediction over here. And again, because of the video large size, I'm unable to display the results in Google Colab. While I have downloaded the results, so let me show you. So one results are of this, like you can see here, we are able to detect the fire. So here, what model is it? Well, yes, it is the model is able to detect fire air as well. So these are fine results. While here also model is detecting fire. So we are able to get some fine results. Let's test on other video which I used. So So in this case, let me check. So here also already detecting the fire. So it is also giving some fine results over here as well. Here the model is also giving some fine results. So our model performs overall fine. So this is the overall demo. So you can just check it out and implement this on your side as well. Thank you so much for watching. See you in the next